Medium voltage power cables are commonly used in the power industry to transmit electricity with a voltage of 6 kV to 50 kV. They are applied in cities as energy distribution cables to power entire districts, factories or large engineering facilities. They are used increasingly often in solar or wind farms and small hydropower plants. In order to take a closer look at their production, we're visiting the ELPAR cable factory in Parchev. Don't you feel the tension already? So let's get started. Medium voltage power cables can be laid directly in the ground, special ducts, culverts, and in the air. If in special seals, they can be used in very demanding environmental conditions. They are designed to work with long-term load at a temperature of up to 90 degrees centigrade, and during short-term short circuits, they can withstand a temperature of up to 250 degrees centigrade. The heart of the medium voltage cable is copper or aluminium, single or multi-strand conductors. We are going to take a look at the production of multi-strand aluminium cables. So firstly, a wire is needed. A lot of wire. We get it from an aluminium wire rod. At the beginning, a coil with 9.5 mm diameter wire rod is put on a payoff unit, from which the material goes to the drawing machine. Here, we get the wires with diameters ranging from 1.5 to 5 mm through a set of drawing dies. There is an automatic spool winding device at the end of the line. One spool holds up to several kilometers of wire. Wires must be twisted together to make a conductor. For medium voltage cables, we need from 7 to 61 wires. The wire spools are mounted, and when the line starts, they unwind and enter the calibrator unit, in which they are twisted and compacted. The conductor is reeled on a spool with a diameter of 3 meters and passed on to the next stage. The conductor must now be insulated. The triple head applies 3 layers simultaneously: the conductor screen, insulation, and the insulation screen. The extruded system enters a 150-meter long pipe where the processes of cross-linking, relaxation, and cooling are conducted. In this way, crosslinks are created between polyethylene chains. The cable path is long, as once turned on the turning wheel, it covers several dozen meters in the opposite direction, where it is finally reeled. In the screening process, a copper metallic screen and sealing tapes are applied. And this is the final stage. Once unrolled and with the aluminium tape applied, a semi-finished product passes through the extruder head. A special plastic mixture is plasticized and pressed under high pressure onto the surface of the cable core. Now it's time to cool down again. The cable goes to the cooling tubs, then receives an identification imprint, and finally goes to the drum reeling device. All products undergo rigorous quality tests in terms of their electrical, constructional, mechanical, and physico-chemical properties. Long-term testing of insulation systems involves immersing cables in water at a temperature of 40 degrees centigrade, to which a voltage of 36 kilovolts is applied. Half the samples are removed from the water after 1 year, and the other half after 2 years. Now it's time for a breakdown voltage step test using the special voltage system to apply voltages as high as 450 kilovolts. In addition, the cables are subjected to electrical measurements in a Faraday cage. Here, for a change, we can see the production of low voltage cables, namely copper conductor insulation. On this line, cables are reeled into coils, wrapped in heat-shrinkable foil and placed on pallets. Every month, 20,000 kilometers of cables and wires for various purposes leave the ELPAR factory. Their 2-month production would cover the entire Earth.